Hey Techno Studs! In this video we're going to talk about proof of work. So in our last video we talked about blockchain and how they're interconnected. But there is a weakness, so let's cover that weakness and how we compensate for it with proof of work. In our last video we talked about this blockchain, and here's the visual that we covered. So we talked about if there is something that changes in this data right here, even if it's like 1 day off with a date of birth, then it's drastically going to change this hash. And because this hash changes and is incorporated into our next block, that is going to change the next hash, which in turn will change the next hash. So we create this triple effect. Now the problem is that although this is going to flag that something has changed, somebody could conceivably go into here, change that data, and recalculate the whole chain. And therefore, there is an integrity issue here, is somebody could cover up their tracks. So how do we compensate for that? So because it's relatively easy for somebody to go and just recalculate the whole blockchain, we slow this down through a process called proof of work. The idea behind proof of work is we're going to slow down the calculation process for this hash. That is, we're going to create this barrier. We're going to slow it down to, let's say, 10 minutes. And it's going to take 10 minutes to calculate this hash. And then another 10 minutes to calculate the next hash, and another 10 minutes to calculate the next hash. Well, it's not going to be conceivable that somebody could go back and change this data and have to spend all of this time recalculating the whole chain, making it very difficult and very obvious that somebody has done this. So that's where we add a bit more integrity through this whole process. So how do we slow down this process? Well, computers are fast and they're getting faster and faster. For them to calculate a hash is no problem for them. They can calculate it very quickly. So how do we introduce something that's going to slow it down? Well, we introduce two things. Number one, we introduce the nonce field. This is an extra number that's used in the whole calculation for the hash. And so we're going to introduce that. The other thing is we're going to introduce some sort of challenge. For example, let's say we challenge it to come up with some sort of repetitive number, or in this case right here, it's 4 zeros. And that can change. It can be different. It could be 1 0, it could be 2 zeros, it could be 5 zeros, it could be 10 zeros, it could be 32 zeros. Some sort of number of zeros at the beginning of this hash. And so what a computer would do is it would start out by checking different numbers, random numbers or sequentially, go through and checking different numbers to figure out when can it find this magic combination that's going to create the desired results. So in the example here, if I'm trying to create 4 zeros at the beginning, then I'm going to put in a 1 in there, or 2 and a 3 and a 4 in that nonce field and keep calculating this hash, and that hash is drastically changing every single time. And I'm going to keep doing that until I find what I'm looking for. And in this case, it's 4 zeros. And maybe it takes me a while to do that. In fact, some of these algorithms will change. As computers get faster, it's going to actually look for more and more zeros to slow down that process till it hits some sort of desired, like for Bitcoin, it's 10 minutes. So it's going to wait a certain amount or look for a certain amount of zeros till the average time to success is about 10 minutes. So that is what the nonce field does and introduces to all of this. The reason why this is called proof of work is because some computer is going to need to work at trying to figuring out a nonce that creates the desired effect. But the other part of this is the proof part. So here's what I mean is that it's going to now create a while. It's going to be a while before a computer can figure out the nonce value to create that criteria, in this case 4 zeros at the beginning. But the proof part comes in when another computer needs to check to see if that device, that computer actually did the work. And that part is easy. As long as it knows the nonce and it also knows the data that went into it, it can take that information and easily put it into the algorithm and make sure that the hash comes out correctly. So another device can easily check, easily prove that this other device did the work to create the proper hash. So if somebody wanted to go back and change some sort of data here, now it becomes a problem because they would also have to calculate the new nonce to figure out the proper hash there that's meeting some certain criteria with that. And let's say it takes 10 minutes to do that. Well, since then, there could be many, many, many more blocks that have been written to this, causing a problem, making it where it's a pretty big hurdle for them to go back and change any prior data.